So, how is course going on?
Going good, sir.
Good, sir.
Okay. Okay. So, we will start in 2 minutes. I have prepared only two questions we received. So, I will prepare the one is from Bhuvan Joshi and another is from Chandra. Are both of
Uh,
you here?
Sir, before that, after that, if you can give us some glimpse of previous year examination or how the exam pattern is there, what kind of exam will that will be coming in the examination, and in the lectures, majority are of theory portion,
Yes, yes,
and in the assignment we have numerical questions.
yes,
So please highlight on those points also, how we are getting the questions, because in last 3 weeks of that is a mixer, oscillator, and power amplifiers course. There is
yes,
a brief overview of the
yes.
points, not a
Hmm.
detailed one, right, sir?
Uh-huh.
So how to prepare for the exam? Please guide on that point also, sir.
Yes, so means assignment, whatever type of question, similar type of question you can prepare. And also there is a around 50-50 percentage weightage. So 50 percentage will be numerical type and 50 percentage will be based on the whatever lecture theory part has been covered. So whatever let's say lecture you are studying, in the last lecture, let's say some of the lectures only theory has been discussed. So on that you need to uh, first understand what has been explained, and based on that let's say objective question will be asked.
That means, sir, 50% of question is kind of recall kind of question, right?
Yes, yes,
And 50% is from the assignment, as
yes,
a numerical question similar to the assignment.
yes, yes,
And sir, one more thing, in the assignment, some of the questions are bit lengthy. We require a calculator to solve those questions, right? In the online calculator, which is having some limitation, or it is very slow. So we request you to kindly give a question that we can do a hand calculation or a minor calculation with the scientific calculation given in the examination, online calculation, because
yes,
physical calculation is, I think not allowed, right, sir?
yes. So
Can I talk?
um,
Yeah, actually,
so there is one of my TA is with me. His name
Yeah,
is Nanshekar. So he
yes,
will answer to your query.
yeah,
yeah, please.
yeah. Hello. Actually, regarding the thing which you have asked about calculations, so I have solved the all calculations using the calculator which has been provided through the portal. So it is
True.
similar to the GET calculator. I use the same. So
True,
in the
but it will take a huge amount of time to solve if there is a lengthy calculation.
No,
So
we did not ask. Generally, the question will be on either multiplication, addition, subtraction.
fine, sir, fine.
So
Okay.
I don't think
But for
any.
stability, right? Like for stability
Stability,
analysis,
S parameters, yes, sir.
S parameters and all the complex calculations are almost
Complex calculation is
impossible.
there, yes, sir. That is
Impossible
the
with
okay, okay.
yeah, true.
calculator. So,
Yeah,
like if the values are easily cancelable, but the problem is once you change to polar and all, like it is really
yes, true, sir. For
impossible.
the stability S parameter kind of question, yes,
Yeah.
true.
So we mostly try to use the online calculator and solve all the problem. So the question will never arise a problem where you are facing this calculation mistake. And if
Fine, sir.
still, let's say, we'll request NPTL to provide a scientific calculator if they can provide.
Mostly like this kind of complex, like imaginary and real kind of calculations, we will take care of it, so that they won't be there in the
Yeah, so we will
Fine.
we will take care that if let's say required, that will be has a minimal, or the means most of the question we have formulated such that your knowledge and your understanding will come out.
Fine, sir.
So
Thank you. And sir, total number of question is 50 or 100?
no that
that we
we
cannot.
don't.
That various question has been given and it will be selected based on the NPTL guidelines. So
No,
you
sir,
can,
my question is total number of question for the examination is 50 or 100? Is 100
so
marks
you can go through the NPTEL guideline. It will be as per the
fine?
guideline.
So no guideline is given for the number of questions in the NPTEL.
You can send email. They will provide if you require.
Fine, sir.
Uh, Is there any other question from any other?
Yeah. Like one question I want to ask, like for example, many of the solutions, right? Like I've tried to put in the Q&A and all. I would like some detailed explanation. For example, in receiver architecture, couple of questions. Impedance matching is okay, like that is procedures. And also in a mixer design, and a couple of areas are there where I'm not able to follow why that answer was there. And if I try in my some conceptual questions, like if the details can be given, detailed solution can be given, that is okay. Another point is like there are a lot of design procedures, whether for amplifier design or for matching or and the various types of various classes of amplifiers and matchings and all, and they are lengthy procedures. So do we have to like and those we have to remember a lot of steps. So is it necessary to have that like full preparation and full strength we have to be in the exam, or like in the exam we'll have some sort of hints saying that okay, follow, do this and all, because master without referring it is not quite difficult to remember everything.
No, I don't think there is any question which required so much remembering, and equation also are not required that much. So
Sir, so it is a filling the blanks kind of question or option will be given?
means it is the exam which will be based on the whatever entire course. So you already have done assignment. So based while doing assignment, did you feel that I required this
No, sir,
equation?
assignment is an open book assignment, na, so it is bit easy for us to solve because we have a
Yeah.
sufficient time. We'll do a internet. We check a book. We solute. We try.
We can look at the book, right? Like that's a very big help.
So sir, जैसे कि sir ने भी बोला, sir, I also write an email to you personally on your personal email ID as well as NPTEL that we require a detailed solution of each and every question given in the assignments to follow the steps. So that will definitely help us in the preparation for the final exam, sir.
So, my student want to elaborate some point.
So I will tell you a few things. Like I have already shared the detailed solution for almost all the numerical solutions. Okay. So I hope you have gone through that. Still, if you are finding any difficulty in understanding the numerical, or like you can like send an email through Q&A, and I will personally respond with a detailed explanation. Usually through email instead of like.
I think, but for I think you said up to 8 assignments, right? Not full assignments. So we are waiting for the rest of the assignment also.
Yeah, that's what I have asked that time. Like I have shared all kind of numericals, but I
up
did
to
not
6 assignment.
Yeah,
Up to 6 assignment. Yeah.
Yes.
So we require all the if it is there in the rest of the assignment, we'll definitely you also share and we'll also raise a query.
Means there is a question and answer session. You are feel free to ask. Let's say in this step you have a doubt, or this step you have doubt. So you just write it. We will explain you how this step has been formulated.
Fine.
And,
so we request sir, your team to please reply as quickly as possible, because in previous experience we are not getting a quick reply.
No, you will definitely get. Exam is coming nearby. So
yes, sir,
within let's say next week of time, try to give all the query so
Fine,
that
sir.
we can reply.
Thank you so much, sir.
Even more than numericals, somehow we can solve, because like we can find examples in POSAR or Razavi. But the thing is, the conceptual questions, right? Like our understanding, like we want to clarify, especially in that Hilbert transforms and how the rotation of the things is happening. So even one question, like if it is cleanly like in multiple steps, like okay, this is rotating like this, so the addition is happening, image rejection, and though I mean, just one example, and maybe one or two conceptual questions with detailed reasoning, so that because we are learning the subject, we have not mastered the concept fully. I mean, what we can do, we are doing, but to if we do, because I'm working professional, like we have to
Yeah.
spend too much time to sort of like, we cannot spend too much time also, right? So that is
Yeah.
why I'm asking.
No, means let's say for inverse transform and other thing, if you go through the lecture, I try to simplify it as much as I can. So and some one example also has been explained where high end injection and low injection has been discussed. So let's say if you are not understanding anything from the lecture or somewhere you have doubt, you can write on email or question answer session. We'll try to reply. So, and the step by step analysis has been given in the solution. So, if you require more steps to understand, we will provide. And let's say if you have some special question where you want some small video, we can provide a 10-minute video of understanding and we will upload. So, that is not a problem. So let's say a specific point if you want us to discuss, you can definitely tell.
Thank you so much, sir. Thank you.
Yeah. So one question was very good question. That is, there are two questions. One is from Bhuvan Joshi. What are the typical specification considered during design of low noise amplifier, mixer, power amplifier VCO for general PDK? So this question, I have made one small presentation. I will share the screen and discuss. Hmm. Yes. So this is a live session. What are the typical specifications considered during practical design of LNA mixer, power amplifier, VCO? So, and there is another question by Chandra. Will we be required to memorize all the complicated formulae for matching, or hints will be provided in the exam? I don't think there is any question which required a memorizing of the equation. So you can let's say some of the basic equation sensitivity and other you if you do the practice you can understand. So that is not like big equation you need to memorize like center of the circle or all the stability.
Noise figure and the Friis equation and sensitivity.
So some basic equation that you should know. And whatever has been covered in the assignment, you will get a highlight what kind of question you will get in the end term. So, if we in the last lecture, I also discussed about the link budget. So, before going, I am answering the first question. Before finding out the specification of any component, first you should know the what is the link budget. So how the your signal will transmit over the air, what is the distance, and based on that you can identify that at what are the losses and how much power has been received, how much power you want to transmit. So that can be provided. So here this is a transmitted power that is coming from the power amplifier, and there is some loss due to the interconnects, and once you put the antenna it will improve the EIRP radiated power because of the antenna gain, and then you can find the path loss. So this is a equation for free space path loss. This is a simplest equation. If you want to find out how the fading and other thing occur, this loss will change, and then you will get a received power, how much power has been received.
The slide is not changing, I think.
Also, what happened? You can keep. You share the screen on and the screen. Yes. Yes. Now is it visible?
Yes, sir. Now we are on a link budget slide.
Yes. Yes.
Fine.
So here you can see that for how much power, transmitted loss, path loss, and then there is a receiver antenna gain will be added. After that, there are some loss between antenna and the receiver, and you are getting some received power, and you define some receiver sensitivity. There should be some link margin between received power and receiver sensitivity, so there are other loss can be considered. So you, before finding out the specification of each object, you should know the link budget. So in order to understand, I have put the two case study. One is a case study of IoT, the receiver which is a 2.4 gigahertz BLE or ZigBee. So here, based on the link budget calculation, if we have a scenario like a BLE device communicating to a gateway over a 10-meter distance. So what are the key parameters you should know? How much transmitted power, that is, let's say generally in BLE it is 0 dBm. Antenna gain is 0 dBi, both are 0 dBi. If distance is 10 meters and your frequency of operation is 2.4 gigahertz, you will get a path loss, a free space path loss by using this equation, and that is around 80 dB. So you will get around
Sorry to interrupt you, sir.
uh,
Just wanted to know, this video is recording, right, sir? You are going to upload this video, right, sir?
yeah, yes.
Is recording is on, right, sir?
Yeah, recording
Fine.
is on.
Thank you, thank you.
So the path loss is around 80 dB. So once you understand the link budget, the next is a you need to find out the receiver sensitivity from the BLE. So let's say your modulation scheme is EFSK and 250 kbps data rate is transmitted. Your required SNR is 10 dB. You can find the noise floor by using this equation. This equation already has been discussed, -114, and you can find the sensitivity which is a -102 dBm. So the first idea about your receiver you will get after getting the sensitivity, that is a -102 dBm you require. Once you know the sensitivity, you can directly find out the specification for low noise amplifier gain and other components. So here some RF front-end specs based on the above calculation we can get. So let's say if you want to find the if you want to know that how much gain and noise figure required you for low noise amplifier. So gain, you must amplify signal. You are getting very weak signal at your receiver, which is -102 dBm. So in order to bring to the ADC range, you or the mixer, you need to have a usable level which is around -70 dBm. Now it depends upon what kind of mixer you are going to use or ADC. You can increase or reduce this gain. So you choose a gain around 15 to 20 dB, that is for LNA. Now we already know that your receiver sensitivity directly impacted based on the noise figure. So you should always target noise figure which is less than 2.5 dB. And your IP3 is not that much critical. You can consider -5 to 0 dBm. On other side, while understanding the IIP3, you should know that what are the types of blocker you need to block. So there are two kinds of blocker: in-band blocker and out-of-band blocker. I already discussed about in-band blocker and out-of-band blocker while discussing the receiver architecture. So based on this blocker, and there are some IEEE standards or 3GPP standard also will tell that how much blocking you need to add. So you will get the idea about IP3 and linearity. And always you need to ensure the matching which is less than -10 dB S11. So now you got rough specification of low noise amplifier. You can start designing your LNA based on this specification. The next is a mixer. If for mixer, let's say you can either choose a passive or active based on your gain requirement. So let's say passive if ultra low power is required. So if you don't want to consume power in your mixer, you can use a passive mixer, or if you have some power left in your design, you can choose a active mixer. So passive mixer generally have -6 dB loss and active has a gain around 5 dB, and you can get higher gain also. Always mixer at the noise, so you should have a mixer noise which will range from 8 to 12 dB. And mixer is a 3-port device, we already have discussed in the lecture, and it has a RF input power, LO input, and IF output. So LO power, you should understand that it should come from PLL. So you should not consider power which is so high, like more than 10 dBm, because PLL cannot generate the power which is high required. So you should keep in the range of 0 dBm or less than this. Then for VCO, you should the two Bayesian specification. One is a phase noise, so you should consider minus 100 dBc per hertz, so that it will not impact on adjacent channel at the 1 megahertz offset, which is the acceptable limit. And tuning range, it should cover entire BLE band, which is 2.4 to 2.5 gigahertz. Now for power amplifier specification, how much power we need to transmit over the air, that based on the link budget you can consider. So output power generally is required 0 to 4 dBm. And your efficiency, so there is I discussed multiple times, there is a trade-off between linearity and efficiency. So we can choose a class AB amplifier, and linearity, BLE has a low EVM, so there is no strict ACPR requirement, because it is a low power and low data rate application. So based on this case study, you will understand that what is the application you are targeting, and based on that how you can design your specification of each component. So this is a one case study I have given. Now if you see the another case study, that is a radar. Let's say if you want to design a transceiver for 24 gigahertz FMCW radar. So for radar there is a different kind of link budget, and based on that link budget you can get the parameter. So let's say if you want to make a short range radar sensing up to 100 meter. The specification for transmitted power 13 dBm, receiver power and gain of the transmitter and receiver antenna is 10 dBi, frequency is 24 gigahertz, and targeted radar cross section is 1 meter square. Based on the radar equation, so there is a separate course you can see on the NPTEL on the radar. So you can calculate the receiver sensitivity minus 85 dBm. Or let's say if you are only RFIC designer, and if you don't, you can get this specification from some of the let's say a designer who is working on the system part. So once you know the sensitivity, which is minus 85 dBm, you can start calculating the other parameters. So then for receiver, based on the receiver sensitivity, step 2, you need to find the receiver sensitivity. So this is a bandwidth based on the time resolution. SNR that is required is 13 to 15 dB. Your noise floor will be minus 94 dBm. So your minimum sensitivity based on S min required sensitivity, your noise figure you will get around 6 dB. So S min is already given minus 85, and if you put this value you will get a 6 dB noise figure. So this is one specification that you got. Now once you got the specification, that you can get the low noise amplifier gain, how much you should have. Critically noise figure you can target less than 3 dB, and linearity should be high, because there are a strong because in radar the same signal will also come back. So you need to have a good linearity in your receiver. Then there is a mixer. You can design a sub-harmonic mixer. So we already have discussed sub-harmonic mixer. So for sub-harmonic mixer, your LO requirement is less. So we can design a sub-harmonic mixer which will has a LO of 12 gigahertz. Why? Because it will simplify PLL and VCO design. It will also reduce the power consumption, because our targeted frequency is 24 gigahertz. Then gain, you can have an active mixer, so that you can also have a gain provided. Then noise figure, which will be around 6 dB, and IP3 also required high. So you can understand now at 24 gigahertz, you need to devote more time, more effort to specific to achieve the specification for the each component. Then voltage can VCO, you required a tuning range 1 gigahertz, which is used for chip generation. Then phase noise you required -110 to -115 dBc per hertz, and KVCO, which should be greater than 300 megahertz per voltage. It is required to do the fast chirping. So this is a VCO specification. Then power amplifier specification, because you need to send signal for long distance, it required a 10 to 15 dBm of power. Your efficiency should be moderate, and you also need to manage the heat. So linearity high to prevent the cheese distortion. So as much high you can achieve. So this is how the first question that has been asked, that how to identify the typical specification considering the design of LNA, mixer, power amplifier and VCO. So you take application which you are targeting, and then you can find out the whatever specification you require. So I hope the first and second both question answer has been given. Anyone has any doubt?
So there is one more question they have also raised. Like, can I touch?
1 minute.
Yeah, actually, one person has asked like regarding videos of assignment solution, detailed video. So that will be there will be an update very soon. I will share about that. If it is a recorded video we will update in the portal, or we will through Google Drive.
Let's say there are some NPTEL guidelines also. So if we can not able to provide the video, we will provide detailed solution which you required.
So and
Okay,
step by step solution.
And recorded video of the solution, like it will be engaged, like if you have any doubt in specific question, that will be discussed. But entire assignment solution, like that will take lots of like time, but I will update about it.
Yes.
Hello, sir. My request is like you must be having RF lab also, right? Like for each of the topics, like matching or like mixers, oscillators, all the subtopics, lab questions must be there, like which are not too complicated, but you can get the answer. A beginner can get the answer and like do some simulations. If you can provide a list of like small lab problems that we can work on and gain the experience.
Yes.
And finally like one semi hard, like of slightly above average difficulty of each of the topics, and then finally one small mini project type of, so that we get but it cannot be completed in like immediately, but like over time, if we are interested, we can solve those problems and like sort of gain practical knowledge of what this field is.
Yes, this is a good point. So let's say this run we got this feedback from you. Now from next run we will try to formulate. We will discuss with NPTEL and ask them that if we can have some assignment which we can get, or something which is a practical needs to be considered. But the problem is there are more than 1,500 students enrolled for this course. So sometimes evaluation will be difficult for us. However, voluntary basis we can definitely give the project, and some where if you require some feedback.
Yeah, no, I do not want evaluation. I just want the questions, like so that
okay,
if we go onto the web, right, all the problems are like usually for very experienced and very good professionals, not for beginners. So I will not like something that takes the beginner to, from beginner to some say average level,
Yeah.
those set of exercises you can
Yes,
lab exercises.
some exercise we will provide. We'll provide that. Let's say low noise amplifier, then mixer, oscillator, power, some
Basic circuit
basic circuit.
design.
Yeah. That's all. Nothing much like
Yeah,
evaluation. I can understand like it is impossible to like do.
yeah. Sure. No, but it
Another
is
thing
good that.
regarding the Smith charts, like the questions of the Smith charts in the assignments are mostly like they don't require you don't have to plot the circles on the Smith chart and find the experimental value. So, so like in the exam, should we be like will some charts be given or like how is it? Uh,
So, like regarding this matching, you need a Smith chart, I guess.
yeah.
Yeah, but in examination, we made sure that there won't be any questions that required a practical Smith chart.
Okay. Okay.
Okay,
Thank you.
and if in case if matching question has been asked, you can solve a equation method. That will be simple thing only, I guess.
Yes, equation method also has been discussed in the lecture.
So if you are troubling to find the like remember the equation, actually that can be derivable, but still we will make sure that it.
Actually, yeah, actually, the equations you said that is a rememberable, but right now we are actually attending more than 4 or 5 NPTEL courses. Many people are the same only, and we have a continuous exam from 26, 27, 3 and 4. Every weekend we have exam. So we have to prepare for the rest of the subjects also. So our humble request you to that you just give a question which is easily solvable
Yeah.
and not that not that rememberable kind of we have
No,
to remember
no,
so many
there are no
equations.
question which required means this is not your memory test that we will keep in your mind. Keep our mind. This is your RF transceiver design course test. So you will your understanding from the course and some basic equation like sensitivity and all that you should know. That only will be there. There are no
Fine,
any
thank you so much,
equation.
sir. Thank you.
Someone Bhuvan was asking some question.
Nothing like, sir, in a continuation to him only, like for self practice, if we can be given some design based questions that we can do in our free time.
Okay, okay,
Yeah,
okay,
in continuation to him only.
okay. That definitely will give. Any other student who has any doubt or clarification required?
Yeah, just like for the lab questions, if you are providing, please also like mention what are the softwares we need, because most likely we won't be working with not real RF elements or real measurement, but maybe some simulation softwares.
Yeah,
Yeah,
so
that,
that
that
that will provide. There are some software are available open source also. Some
yeah,
software are available to the student for 1 month to as a trial basis. So you can use those software. So that
We will let.
we will let you know.
thank you.
There is a question.
Yes, so one question is how can we calculate gamma S and L and values whether only from Smith chart or by formulas? How to fix this value for matching purpose? So this source reflection coefficient and load reflection coefficient. So I always means in my slides I discuss the two way of designing. One you can design by using a Smith chart and one you can design with the equation. So gamma S and gamma L, that is a value that you get in order to match to design the impedance matching network. So uh, that you need to use a Smith chart. Now if you can also use a equation based method and circuit method. So in low noise amplifier I discussed that how you can find input impedance, noise figure, base formula, and you can design the LNM. So there are, it also depends on the application. Let's say if you are designing for less than 10 gigahertz or 7 gigahertz, you can consider the methodology of the equation base. But when you are designing, let's say, receiver for millimeter wave or sub terahertz, very high frequency, there you need to consider effect of gamma S, gamma L, stability. So these all parameters are important. So how and what is your application that you are targeting? Based on that, you can uh, use the methodology to design. But whatever methodology you use, you should achieve the specification that you are targeting. And you require some simulator. Initial design you can start with the calculation, but later on you require a simulator. So in last slide, I think lecture 60, I discussed the importance of EDA tool in RFIC. So that is also required. For circuit design, Bhuvan has asked, can we use LT Spice? Yes, you can use LT Spice. So there are some high frequency requirement of the transistor models. If it is there, then you can definitely use LT Spice or ND Spice. Your models of the transistor should be as accurate as for that can be used for that frequency. If it is not that accurate, then you can go through the other software which will provide the more specific simulation data.
Am I audible, sir?
Yes, yes.
For the circuit simulation, you can use the ADS also if you
Yes,
want.
yes. You can use
ADS
it.
is a better if you have a license version, or I
So,
think if you are a student, then the student version, if it is there, the ADS is a nicer software to design your circuit and complete, go to the layout and fabricated and tested. So it
yes.
will give you the closer result with your simulation results.
Yeah, so you can use a Keysight ADS, you can use a Cadence, you can use Synopsys. So there are various tools are available for designing the circuit which will give you the more accurate result comparable to the simulation. Any other question? Anyone else?
My question.
Yes, so one student has a one question that can you please show us an example in software? So this is also one of the good questions. So this leads me to make a next course I am planning to make, where not only the theory but only with practical some design can be explained. So that we are planning to make some new course where we can explain the methodology by using the particular software tools. So wherever it required in the this course, I have tried to explain certain place with some simulator how to use. But how can we design with the example software? That is a separate requirement. One more question: is it so? One question from Arivajak Dravid Selan, that is it enough for matching network by calculating formula itself to get more gain, or else it need optimization to get more gain? So for if you are doing the calculation, then you will get a value which will roughly closer to the requirement. Now when you are finding the input impedance matching, what you are considering is your input impedance of your transistor is remaining constant for all the frequency range that you are designing, or whatever model that you have used are accurate. But when you go to the simulator, then what you need to do is first to use a whatever method, whatever design parameter that you have calculated, that you use first, and then you need to start optimization. So for optimization you require a software. And so LNA, it has been asked. So there is always you need to do the optimization once you have done the calculation. But calculation always helps to understand what results you are getting is correct or not. Because simulator, whatever you give input, it will give some output. But if you have understanding of calculation, you can use it to that your tools are and whatever result you have calculated are aligning to each other. I hope the question has been answered.
I've got another question regarding measurement techniques for various things, for finding out the parameters, either of the parameters of transistors, those high frequency transistors, or the transmission line, or of all the elements. The measurement techniques, I think, are very important. Could
Yes.
you sort of like guide us on that, like for practical design, actually, the
So
limits and the errors and
I think
tolerances?
in last two lecture, somewhere I discussed the measurement. So that is finished.
That is there some, but
So
That is
you
on
can
last
go,
lecture, yes.
means I have given some flavor to understand the measurement. So now we in our institute we have a separate course and on RF and microwave measurements. So how you can apply whatever you let's say whatever parameters you have and you want to identify, there are separate techniques and tools and let's say equipment are used which will help to find out the particular parameter, S parameter, then IP3 and other thing. But I think many places, let's say while discussing the noise figure, I have tried to explain some, give a hint. Please. I have tried to give a hint that how you can measure particular components, particular parameter, let's say noise figure. IP3 also somewhere I have
Yeah, yeah. In the middle of the course in lectures 6, 7, 8, 9, also there are a lot of places where you have referenced those things.
Yes.
So like I wanted to like some sort of guide or some pointers to where I can find more information on them. Yeah, like that.
So there might be some NPTEL course, or in future we are also planning to have some course on RF and micro measurement, which is also very important course to understand the complete RF IC design.
Thank you.
Anyone else? There is a Vivek Kumar, Mohan. There are more than 10, there are many other students. So I hope all of you understood and have a fruitful this live session.
Yes, sir. Thank you so much.
So there is one question that for LNI circuit is unconditional stability, but I couldn't get to satisfy enough gain. What are the other procedures to improvise the gain? So yes, so if you for improvising the gain, let's say if you have only S parameter is provided for the transistor, then for improvising the gain there are two methods, either you go for a cascode or you can use a cascade. So you use a multiple transistor to increase the gain. So that is a one method. Or otherwise, if the device parameter is in your hand, then you can try increasing the transconductance of the amplifier. What are the you can find the gain formula. Let's say if your gain is depend upon the GM of the transistor and the load. So how you decide the your load, how you design, and your GM, equivalent transconductance of your circuit. So if you optimize both, you can achieve the gain. So your S21 should be high. So if your S21 is high, then you can achieve the higher gain. I hope you understand. Okay. So I hope now there is no any question, so we can stop the session. So if anyone has any question answer, you can put a question answer on the portal. T and we will try to update immediately. Okay.
Yeah, thank you, sir.
Thank you. Thank you all.
Thank you all.